due to road and housing development. So we have it all. First, a small introduction. This is the Mountain Institute where I come. Winter sports, climate change, artificial snow and winter sports, a big section. Applications of environmental indicators, lessons learned from the Alps, and then last but not least, ski tourism, climate and ecology in China. So, starting with ecological and hydrological impacts first, I will go through 3 scales. You may say that all these effects are not very important because they're just local scale, but lots of local scale effects add up and can alter and go into ecological chains and have long-term effects. So, if we look at classical example of pist grooming, especially with artificial snowmaking nowadays, the pists have to be well prepared, but this has a major impact on vegetation, soils and rocks. So the pists have to be kept without, the pists have to be kept clear of vegetation. Vegetation is often damaged. Then, because the snow is compacted every day, or let's say every night, the soils become very impermeable, the water cannot infiltrate, it stagnates, because the snow is about 60 times harder and 4 times denser. This means that water cannot infiltrate, stagnates at the surface. Then together with soil compaction and decreased infiltration, we have all the classical problems of runoff and erosion. Now let's go one step higher, the slope scale effects. These are maybe sometimes most obvious for ski infrastructure, artificial snow infrastructure. Lots of pipelines have to be laid. These create preferential local drainage patterns and increase runoff and erosion. Then of course there's lots of major embankments being made for ski runs. Sometimes even whole rock faces are exploded to create motorway-like runs, and this has lots of local effects again, erosion at the bottom end of the slopes, sometimes up to a few meters of erosion depending on the slope steepness. And then another problem we have is the lack of recovery because of the short vegetation period. So in the Alps there's usually no real recovery above 1,600 meters. Below, the pists are usually well revegetated, but above we have a vicious cycle that because there's no revegetation, erosion continues and becomes deeper and deeper. For areas like China, this limit would be lower. So these are some of the regional scale effects. Again, we can see here a concentration of artificial snow fields in preparation for the winter season. Very deep-seated erosion here along the black ski runs. Housing development higher and higher up into the mountains. Again, slope erosion around the new housing and new road development. So with the effects of climate change, global warming, our limits are being pushed higher and higher into the mountains. At the same time, the surface area that is available is decreasing. So, yes, just to summarize it. Oops, doesn't seem to be working anymore. Hello? Yeah, now it's working. So, to summarize the 3 points again, slope erosion and slope failure. Then, this is another image in a mature ski area in the French Alps, Les Arcs, as an example. We can see lots and lots of roads and lots of ski runs cutting through the forest. So this high density of roads and the ski runs, first of all, changes the local hydrology. Here we have about 1 million cubic meters of water surplus per year being pumped from one basin into this basin to produce snow for the runs. The torrents are naturally erosive, and with this surplus in water there will be even more intensive erosion and slope erosion and torrent erosion. The other point is that a new study from Switzerland has shown that this the very intense ski runs through forest will change animal migration routes, and grouse, for example, has shown that grouse population has decreased by 40% in ski areas that have this kind of density. This is due mostly to noise effect. Yeah? So let's go to the second thing, climate change, artificial snow and winter sports, very tightly interlinked. We all know about climate change, we all know about increasing temperatures, increasing global sea level rise, and most important of all in the Northern Hemisphere, steadily decreasing snow cover. Huh? That's a fact, and it's even more a fact in the Alps. If we take example of the French Alps, we have up to 4-meter decrease in snow depth over the last 30 years in some regions. Here, Saint-Martin, Belleville, it's about 1 meter of decrease. But 1 meter of decrease at a certain altitude means enough snow for skiing or not. So this is what we would like to have. In German, der Winter kommt und wir haben Schnee. The winter is coming and we have snow. This is the illusion that we have nowadays. And of course there's a lot of pressure of snow reliability, especially for winter sports. This is Val d'Isère, just very recent photos of the winter games there. All the pistes were prepared by artificial snow, and the fresh snow that fell on the ski runs were removed. They were not good for the ski, for the quality. So nowadays more and more artificial snow is produced and in effect to solve the snow problems, both temporally and spatially, because our snow season is being reduced and our snow depth is being reduced. So is this really a solution? This is a funny picture from Switzerland. Nordic ski run being made. Is this what we really want? Is this what we also want as tourists? Or here a ski run in Zermatt, due to global warming, the last 500 meters are no longer connected by natural snow, so the ski run is completely artificial. Artificial snow, what is it about? It's really about water, and you can see on this picture it looks like a whole chain of showers. And artificial snow is being produced when temperatures are too warm in this case, and there's no snow lying on the ground. But I just showed this picture to show you some of the quantities of water involved, 3,700 cubic meters per hectare. You can only produce snow at temperatures -3. For you here in HARBIN, -3 is not very much, but for us it is, that's a threshold temperature, and with global change and global warming, we're coming closer and closer to the 0 degrees. Yeah? So above this temperature, artificial snow really melts or cannot be produced optimally. So that's a real problem for the for the Alps, for the European Alps. Artificial snow production is very energy intensive, and costs are rising with global warming. Because the warmer it gets, the more the snow melts, the more you have to remake snow, the more water you require, and so on. So it's always a cycle. And where do you put the water? It's not enough to take the water from the rivers, because there are more and more downstream conflicts with the villages. So we are looking at enormous dimensions nowadays at 2,200, 2,500 meters altitudes, construction of lake reservoirs, which of course in some cases have destroyed wetlands, and the environmental groups are not strong enough to prohibit this construction, so biodiversity hotspots are destroyed. And as we know, at this altitude, recovery will be very, very slow. It will take hundreds of years, like in the Arctic, for any kind of this change to recover. There are increasing reports of conflicts with agricultural pastoral, because, as I said, topography is limited, surface area is limited at those altitudes. So also the farmers with their cows and herds have small areas to feed, and there are increasing space and area problems. Then storage. Will there be water deficit further downstream? If you store, if you change the local hydrology here, of course you will have downstream effects. What about conflicts with human water use? Already 1/3 of the tourist resorts in the French Alps have drinking water conflicts, because water for snowmaking taps the drinking water supplies. And when there's a very, very large pressure of tourists in winter time, there's just not enough natural water available. So this is the preparation of such a huge water reservoir, and nowadays there are hundreds of these reservoirs in the Alps. There are nearly 80 alone in Savoie. Yeah? So this really changes the whole hydrology. They become impermeable, it changes infiltration and so on. At these altitudes normally there's high infiltration and high water exchange. And once you fill these reservoirs with water, of course you're exposing it at very high altitudes to evaporation, especially in summertime, also in wintertime, because in wintertime they are not covered by snow. They remain snow-free because the water has to remain liquid. So we are estimating about 30% water loss, which does not return into the basin due to snow making. But to cheer you up, this is the Mont Blanc. This is our highest mountain in the French Alps, 4,800 meters in the background. And you can see that up here on the mountain peak, it's maybe also visually not such a nice image, not such a nice visual impact of such a water reservoir at the peak of a mountain. So there are many studies in Switzerland on the impacts of this artificial snow melt, which is later in the season, about 3-4 weeks later in the season, since it affects vegetation. We at the University of Savoie did modeling, hydrological modeling, on the effect of water surplus during floods. So if you imagine a normal flood, this is the blue line here, over 24 hours, the yellow line indicates what the flood discharge will be like with the surplus of artificial snow melt. And you can see that in yellow line, the flood peak is about 30% higher. Yeah? So the flood peak can increase by up to 30% due to additional melt from artificial snow. And this is just for one event. Of course, snow melt also changes the season, the seasonality of hydrology for the local torrents. And with this, the whole ecosystem is changed. So why are there such big differences between natural and artificial snow? I don't know if you've ever seen a picture of artificial snow. It's actually ice crystals, and the ice is frozen so quickly that sometimes air is still trapped in the ice crystals, which means that this ice, artificial ice actually can melt and refreeze very rapidly. And it's much harder, much more compact, much more resistant. One crystal can be 15 times smaller than a natural snowflake.